What we're going to look at today is how to solve equations. And this is where order of operations becomes really important. Aaron and his mother spent $56. So as we're reading word problems, it helps to actually write down the math, the numbers. So Aaron and his mother spend $56 to take the ferry from Vancouver to Victoria. Aaron knows that the cost for each person is $11, which means that $56 has to include two people at $11 each. He decides to model the situation with the equation C plus 22 equals 56. Why does he do it that way? Yeah.
Well, see, like, what else they got. Because you have to figure out what 22 is not.
Where does he get 22 from? Yeah.
Probably put from like the variable probably cost is like the same number that if you add it by 22 it equals 56.
That's absolutely true. The C is a variable that when added to 22 is going to equal 56. But where did the number 22 come from? Yeah.
2 times 11.
2 times 11. So it's $11 per person. There's Aaron and his mother, two people. So he's already done the math. Aaron, when he's modeling this equation, he's just already done this math. And then plus the cost of the car. How could he determine the cost of the car?
What?
Yeah.
By subtracting 22 from 56.
Okay. So based on what you've said, C plus 22 equals 56 minus 22.
No.
What else do you have to do? Emily?
Minus 22 from 22.
Yeah, you need to take the 22 away from both sides of the equation. Remember, we picture equations like balances. Whatever's on one side has to be equal to the other side. 56 on one side, C plus 22 on the other side. If we're taking 22 away on this side, we also have to take it away on this side. What's 22 minus 22? 0. So it cancels each other out. So we only end up with C on this side of the balance. And we've got 56 minus 22. What's 56 minus 22? 34. So we've got 34 on the other side of the balance. What does that tell us?
C equals 34.
Good. Now turn it back into the problem that we were asked. What were we supposed to figure out?
I think what C
Yeah.
what the variable is.
Yeah. Yes, you were supposed to figure out what the variable is, but look at the problem. Seriously, turn back to your textbook. Then share with someone. The variable represented the cost of the car. So in problems like this, you have to be able to write the cost of the car is $34. Because it's a word problem, we need to turn it back into words after we're done. Okay? So, explore. Hilda's grandmother gives her $5 for her birthday. Hilda puts this in her piggy bank and now has $12. How much money did she have before her birthday? What variable do we want to use to represent this? Yeah.
B for before.
Perfect. B for before. So $5 plus B equals $12. What's our constant? Sean?
$5.
$5, because this does not change.
Also 12.
Also $12, because this does not change. And we have B, which is our variable. Okay. Using a cup and coins, we're going to draw this out. So we have, I don't want to use a cup. I want to draw a piggy bank. But okay, we have some amount of money that she had before her birthday. And then she got 5 loonies. Because she's young and it makes her feel like she has more money. And then that equals, I'm not drawing the dollar sign on each of them, 12 loonies. Okay. Remove 1 coin at a time from each side of the equation until only the cup remains on the left side. We take away 1. Notice how we're doing the same thing to both sides. We take away another. We take away the 3rd. We take away the 4th. We take away the 5th. Now all we have, because these are all gone and those are all gone, is the cup on one side, and we have how many coins on the other? 7. How many coins did you remove from each side of your model? 5. So we had, I'm going to rewrite this, b plus 5 equals 12. We took away 5 from both sides. We only had b left. And we had 7 coins left on the other side. So how much money did Hilda have before her grandmother gave her the birthday money? Yeah. $7. We write that out because we go from word problem to math back to word problem. Hilda had $7 in her piggy bank before her grandmother gave her money. And then it says, what equation can be used to represent this problem? Well, we already did that. We did that here, and then we did it here again. What's missing from what we just did? Not the math.
Well,
What are we supposed to start with?
let's start with start with 5 plus b.
No.
No.
No, not the math. It's not this specifically.
We're supposed to write what the actual point of the question is, like figure out. But that's like
Of the lesson. We didn't write our learning intentions down. So we need to write our learning intentions. And I'm going to put a little arrow.
oh, you mean the focus on?
Yeah.
I wrote that down.
Excellent. I did not. Okay,
I did
so
while you were talking.
I can model problems with equations. I can solve equations and record the process. Oops, and what do you think they mean by record the progress? Yeah.
Kind of like show each step as we go.
Yeah. Show your thinking. Yeah. I can verify solutions to equations. What does that mean? I can verify solutions to equations. Yeah? I'm sorry, I can't hear you.
You can like verify like the depth of the hardness of it, so like if it was like 3 plus 8 and then answer or actually making it harder, easier to figure out.
Okay. Yeah, Ellie?
You can check over it and make sure it's true.
Right. How would I check over this equation? Where 5 plus b equals 12, and we've solved it for 12 or for b equals 7. How would I figure out whether I've actually got the correct solution? Yeah. Yeah, I plugged my variable back into the equation. So if b equals 7, then 5 plus 7 should equal 12. Does it?
Yeah.
Then I know that my variable is correct. I want you to look in both of these cases. What did you do? What operation did you do to both sides of the equation?
-5.
We didn't subtract 5 on both sides, but we did subtract. That was the operation that we did. Why did we subtract from both sides? Yeah. Yeah, we're doing the opposite operation. So here, the equation has us C plus 22, B plus 5. We're doing the opposite operation. If it's written like this, 5 plus B, there's no operation here, right? How would you know whether to add or subtract? There's no operation in front of 5. How would you know that you're supposed to subtract the 5? Yeah.
Because you could try both.
Okay, you could try both. Yeah, what would happen if we added 5 to both sides? What would our new equation be? 10 plus b equals 17. Right? We'd be adding 5, so that would become 10. That would become 17. Yeah.
I'm confused because there's nothing in front of 5, so why do you have to add or subtract it from something?
Because we want to figure out what b is. We want to figure out what our variable is. I'm going to turn the page over here and rewrite this. So if it's written 5 plus b equals 12,
Yeah, then we just do 12 minus b, 12 minus 5.
so you are doing something. You're subtracting 5 from both sides. Remember our little equation
okay.
thing, right?
I understand now.
But how do you know? Like, we're talking about, yes, you have to do the opposite operation, but there's no operation in front of here. What do we know about addition that might make this easier? It is the opposite of subtraction. That's very true. Does it matter what order you add things?
No.
Is 2 plus 3 and 3 plus 2 the same? Okay, so with addition, we can switch the order without having any impact on what the actual equation is. We can change this to b plus 5 equals 12. So that's one way of knowing what you're doing. The other thing is, we haven't done integers yet, but what is this? Positive or negative 5? Positive. There's no number in it. It's always positive. How can you get rid of 5 positive chips?
By subtracting and subtracting.
By doing 5 negative chips, taking away 5. Okay? So positive, the opposite is negative. Okay? Negative 5 plus b is the same as b minus 5. Because again, we can switch the order. When you're adding a negative number, it's like subtracting. Okay? Why do you have to apply the same operation to both sides? Yeah. To keep our balance beam equal.